We've figured out, okay, on the papers I see, and everybody knows how to do this now. So we have at x equals -7, -4, and 3, we've got our zeros. If x is a really big negative number, all these things will be negative. You got 3 of them here, 1 of them here makes 4, and 2 of them here makes 5, so it's 6. So you got 6 negative numbers to multiply together. It's going to be positive, it's going to be really big. So we know that it's like this, and yeah, that's exactly what you have, okay? And over here, it's going to do this, because all these numbers are going to be positive, so you're going to get a humongous positive number, okay? Now, at -7, x plus 7 is squared, right? So it's going to act like an x squared function near this point, okay? So it's exactly what it does. It comes down here, and it does this, okay? Well, to get back to here, it's going to have to come up here and come back down, right? Now, the only catch is that this one comes from x plus 4 cubed, okay? So it comes from x plus 4 cubed. It's going to act like the x cubed function near this point. It's going to act near this point like the x cubed function does at the origin, where it flattens out and then goes on. Of course, it's going to come up from up here, so it's going to be backwards. But it's going to come up like this, down like this. Going to flatten out before it goes down, then it's going to come back up through here. I missed it, but you see what it does. Okay? And the other thing is, when you do this, sometimes you're kind of better off not even drawing the y-axis until you're done, because that way you're not going to be tempted to try to make this the low point of the curve. The curve's going to do what it does, and it's almost never going to have the low point or the high point at the y-intercept. Now, I'm not going to penalize you if you do that, but you don't go out of your way to make that happen. Okay? Just to refine what you're already doing really well. Okay? So, and this point, of course, will be, I don't know, 7 squared is 49, 4 cubed is 64. 49 times 64 is probably 200. So it's about close to 9,600. So that'd be about 0, negative 9,600. Okay? It's going to have big values. And when you go out past 3 and on the left to -7, they get even bigger. They get really huge. Okay? See, the only thing I'm not on this is I like this. Everything else is great. Okay, which is pretty much the case here. And on this one, you understand that note. Yeah, now this slope is probably not 0 there, but the way you drew it, it is, and that's good. Okay, so according to the way you drew it, you nailed it. But we want to test that, and we'll talk about that in class. Yeah, and you can test it by saying, okay, what is the slope here? Well, let's just go from negative 0.1 to positive 0.1 and figure out the fundamental triangle. Okay? You plug those numbers in there, it's not that hard. You want to use a calculator, which is why we haven't done it so far. You start relying on use calculators to do that. It's really good. You didn't say what the function is there? But given that you're doing everything else right, I assume whatever you did was right. Just documentation, good idea. Right on those functions. I think that's a real good job. Okay. how are we doing with the simultaneous equations? Did you have some simultaneous equations on that? I don't think so. Yeah. Yeah, I don't think so. I'm trying to think of, let me look at what some other people are doing here just to, yeah, seeing mostly. Election now. Oh, here's one. This is yours. I thought I saw some. Thought I'd saw. That guy must have bumped me in the head a couple of times when he wrestled me. Delayed reaction to the concussion. And you know, when that was happening, it was really frustrating because I wanted to be down at the pond throwing people in. And it was all the way up just outside the door of the fraternity. But it was it was more memorable than most of the ponding, so. Okay, this off somebody else's paper. No, actually, so, okay, you don't mind me calling you out, Erica, because same thing happened with everybody else. We haven't really done the stuff, so I want to take a couple of the equations you got that look really good and finish the solution, okay? So everything was good, and you did everything I could expect. You got down to these equations. I didn't check all of your arithmetic. Just be an exercise in futility because I know it was right because you did it. Okay? And it almost always is. So that's good. You're better at it than I am, which really isn't much of a compliment. Okay. Okay, so. Uh-oh. I was saying nice things about you on camera.
That's all right.
Okay. Well, okay. Well, you're doing good work. Okay. So let's see. Well, since the blame camera's going, I'll just keep it going. Okay. So what this comes from is, of course, we've got some data points, and we fit a curve, and we test to see if it's quadratic. So we pick 3 points. And they reduce down to these 2. Okay? Because you already know what your C is and all that stuff. Okay? Okay, well, what do we do now? Well, I'm going to say this is equation 1, this is equation 2, And we want to get these b terms so that they're equal and opposite, so we can add the two equations. B will go away if we get them equal and opposite, okay? And then we just have an a term equals some number, okay? So I know that if I multiply the first equation by this number and the second equation by the negative of this number, I'm going to have 72 times 34 up here. I'm going to have negative 72 times 34 down here, right? So that'll take b, okay? And in general, that's probably what we need to end up doing. We can get away with slightly smaller numbers. (36 and 17). Okay? Because 36 and 17 are the same ratio, 72 to 34. If you divide 72 by 2, you get 36. Divide 34 by 2, you get 17. So it's still going to work out. They're still in the same proportion, so they're still going to make the b terms come out the same. So if you can take these two numbers, maybe even think of them just for a minute as fractions, and see what it would take to reduce them, then the reduced numerator and denominator are what you would use to do this. Now, it's not going to help much because the number is still going to be really big. But we get 36 times 1156a plus 36 times 34b equals 36 times negative 75. And down here, we're going to get negative 17 times 5184a minus 17 times 72b equals negative 17 times negative 122. Now, 36 times 34 is equal to 17 times 72. Because 36 is half of 72, and 17 is half of 34. Okay? So these two end up having to be the same. Now you can multiply them out and see that. You probably should, especially since you have a calculator. It's easy to do. Of course, you're going to use a calculator to do this, and I'm just going to estimate it. This looks like it's going to be in the neighborhood of 36,000, and then that's going to get you up to 39,000, 38,639. That's going to be pretty close to 40,000. And that's going to be like negative 85,000, 88,000, so 40,000 minus 88,000. I'm going to say it's maybe about 48,000. Okay? And you're naturally going to use your calculator and get it quicker than I did, but that's going to be more accurate. Okay, 36 times negative 75 is negative 2,400. This is positive. It's going to be 1,700, but then 2,400, a little over 1,700, 400. I'm going to say maybe just picking a number that's easy to divide by 48, negative 360. Now I'm just illustrating all these numbers are highly questionable. There's a fairly good chance that they're in the right ballpark. So we get A equals negative 360 over negative 48,000, which equals 0.0075. I'm pretty sure that is right. Now, the whole point is, you know how to do this once you get this down here. Then your calculator will do these numbers for you accurately. The point is, you pick the numbers here. It always works if you multiply this one by this coefficient and this one by this coefficient, okay? Because then I have the same two numbers. If you can divide both coefficients in half or by 10 or whatever, then you can use those numbers. And of course, you got to multiply the whole equation or you change the solutions. You can't just multiply this. You got to multiply the whole equation. When you do that, you get this, and then you take this to complete the illustration. You substitute it back. I'll just substitute it here because it's easy to draw the arrow here and I don't have to go all the way up here. The number's going to be big anyway. Okay. So that's going to be a 54. It's going to be 0.54. No, I got a substitute for A. Oh, that was so much trouble. I did it wrong. Okay. Okay. Multiply that by 5184. If I multiply 0.01 by 5184, I get 51.84. And if I then do 3/4 of that, 3/4 of 48 would be 36, 3/4 of 51 would be about 38. So I'm saying that gives you, okay, 51.84a plus 72b equals negative 122. That'll be 54 times 0.00. I should have done that. That's better. $51.84 times 0.0075 plus 72b equals negative 122, and I got that somewhere around 38. Okay. And let's make sure that makes sense. Yeah, it makes good sense. Okay. Plus or minus 1, I think that's probably right. So then we add the negative 38 to both sides, we get negative 160. So B is negative 160 over 72, about 2.3. Again, don't believe my numbers. Okay, but that's the process. Now, we could go back to one of the original equations. Let's go ahead and do that and just see if your model makes sense. Okay? We go back to one of the original equations now. We take this and this, and we plug them into the equation well, yeah, we'll do it. 72 squared would be about 5200A. Plus 72B plus C actually would be this. And we plug these numbers in here. So B would be this number. A is going to be this number. And we're going to get And I've got this one wrong. It's negative plus this plus this. Should be 172. And no, it didn't. 148. Which I think is exactly what you estimated. Okay, do you understand what I'm showing? That's one of your equations, if you square it out and everything, okay? Now, it's unnecessary to do that because one of your equations was just C equals 148, okay? And the fact that that came out 148 means my numbers here must have been, I don't know. Okay. What do we do with this after we get the solution? So our solution is and that's negative 2.3. So we get y of t 10075 t squared minus 2.3 t plus 148. Okay? Now how does that fit the model? Does that fit the model well? So how does that model fit our data well? Okay, why is there writing on here? I thought I had a blackboard there. Right, just a second. That's better. Okay. Does this model fit our data? If I did my arithmetic halfway right, it should fit fairly well. Because of uncertainties in the data, even if I'd done my arithmetic absolutely correctly, it's not going to fit perfectly. So we have to check how well it fits. So this time I will turn off the camera before I say anything nice about anybody, but you did a good job. Okay?